All right, this lesson is about finding intercepts so we can graph a line. So I have chosen here 3 specific examples for us to go over. So before we start the examples, just for you to make sure you comprehend the intercepts. X intercept is a point on the x-axis. So think about this. Anywhere on the x-axis, I'm not going up or down. So because I'm not having movement up or down, the y value will always be 0. That's why when we're finding the x-intercept, we are allowed to substitute y with 0 automatically. Opposite case, when I go for the y-intercept is a point on the y-axis. Anywhere I'm going on the y-axis, I am not moving left or right at all. So anywhere on the y-axis, the x value will always be 0. So use the concept of x being 0 when you're trying to find the y-intercept. So as I simply call it, for the intercepts, you set the opposite equal to 0. So let's start the first example. I'm going to start by setting up my parentheses, and I'm just going to go and find my x-intercept first. Technical issues. Let me just erase really quickly. Erase, there we go. And okay, hopefully we're back in business here. So because I'm starting by finding the x-intercept, I'm allowed to set y equals 0. Now think about this. Setting y equal to 0 means this whole term is gone because 2 times 0 is 0. So I'm solving negative 5x equals 10. I need to undo the multiplication, so I would divide both sides by negative 5. And of course, a positive or negative is negative. So I'm getting that the x value is negative 2. So I can put it here. Let's go for the y-intercept. For the y-intercept, if I set my parentheses, the x value should be 0. If x is 0, this whole thing is gone. I try to cover it with my hand sometimes. So I'm really solving 2y equals 10. I divide by 2 to get y by itself, and I'm getting y equals 5 because a positive of a positive is positive. So I have the x-intercept, which means y equals 0, and I have the y-intercept, which means x equals 0. Now, if they ask me for the x-intercept, I would say the x-intercept is negative 2, but if I want to put as an order pair, I would put negative to 0. If they ask me for the y-intercept, I would say that the y-intercept is 5, but if they want me to put it down in order pair, I would put 0, 5. So this is an easy method for me to graph the line. So let me go ahead and put some dots here. And so on. All right, so in order for me to find negative to 0 from the origin, I will go 2 left, and I'm right here. And in order for me to find 0, 5 from the origin, I would go up 5. Now, it would make sense because since I'm graphing by using intercepts, one point is on the x-axis and the other is on the y-axis. And then I'm graphing the line. And there you have it. Let's go to the second example. Well, the second example looks kind of weird. I don't have y in there at all. So, I don't know. Let's see here. Well, if I solve this for x, there's something particular about this. I'm getting x equals 3. Does anyone remember what kind of line is x equals a number? X equals a number, unlike the x-axis that most of you think, that should be the opposite. X equals a number should be a vertical line. So think about this. A vertical line at 3 would be right here. So here's the question. Do I have an x-intercept? Does this line cross the x-axis anywhere? The answer is yes. It crossed the x-axis at 3. So my x-intercept would be 3, 0. Think about this at the beginning. Since y is not in the picture, if I set y equal to 0, I would get x equals 3. Now, because y is not in the picture, I can't do anything about that. And actually, according to what you see here on the graph, in this specific case, I don't have a y-intercept. The line is not crossing the y-axis anywhere. So if they ask me for the x-intercept, I would say it's 3. Therefore, the point would be 3, 0. If they ask me for the y-intercept, I would say none. Please don't put 0 because 0 is a value. None. Because this line is not passing from the y-axis. So yeah, sometimes we don't have to have an x or a y-intercept depending on the case. So we have just learned here for a vertical line, it doesn't make sense for me to be talking about a y-intercept. The opposite is still true. If you have a horizontal line, unless it's the x-axis, you will not have any x-intercepts. Let's go to the last example. X-intercept. Well, hopefully by now we know what's going on with the process. X-intercept set the opposite value equal to 0. If I set equal to 0, that value, this whole thing is gone. So I'm solving 4x equals 6. Well, this is not going to be an integer. Doesn't matter. If I simplify that 6 over 4 by 2, I'm going to get x equals 3 over 2, or 1.5. 3 over 2. All right, that's my x-intercept. For the y-intercept, I'll set this equal to 0, and I'm going to go to my equation, and this thing is gone. So I really have to solve 2y equals 6. I divide by 2, and I get that y equals 3. So again, for x-intercept, if they ask me, it's 1.5, but if I wanted to put as an order pair, I'm going to say 1.5, 0. The y-intercept is 3, but if I want to put as an order pair, 0, 3. Let's go ahead and graph now. All right, I'm at the origin, and I need to go 1.5 right and stay there. That's going to be the x-intercept right here. And the y-intercept is from the origin 3 up. And there's my line. The lines can be extended in any direction, so I have to pair arrows on both of the sides. There you have it. Go tackle task 4 now to do your graphic organizer.